Hello there and welcome to the end of year exam revision video. Here we're on revision video 2 out of 4. We're going to go through the topics in questions 4, 5 and 6. So the way this video is designed is that each question, pause the video and answer the question. A proper go at the question, try really hard on it, not just 20 seconds and then give up. Then play the video to see if you were correct. And if you weren't, then try to remember what you need to do next time so that you know what to do. And try the question again the next day to see if you've got the question correct. So this video will always be available to you whenever you need to use it. So we're going to look at questions 4, 5 and 6. Question 4, Pythagoras Theorem. Question 5, tree diagrams. Question 6, simultaneous equations. We've got some Maths Watch clips here for you to use if you wish to do so. But as we go through the topic, have a piece of paper on the side and you can write down the most important ideas to make yourself a little revision sheet to help you out. Alright, let's get stuck on the first questions then. So pause the video and make sure you have a go at this question. Grab a calculator as well because you'll need one of those. Okay, the first question is two sides of a right angled triangle. We've got to work out the missing side. And Pythagoras' theorem tells us that it's a squared plus b squared will equal c squared. And c is always the longest side on the right angled triangle. It's always the side called the hypotenuse. And then A and B, it doesn't really matter what way round you put those two. So it's A and B on these sides here. So A is 4, so we need to do 4 squared plus B will be 7 squared. And then we need to work out what that is equal to. That's equal to C squared, so it would be the square of this side here. So 4 squared, that's 16. 7 squared, that's 49. And then that's equal to, I'll add it up together on the calculator, it will equal 65, will equal c squared, but then the final thing you need to do after you've worked out what c squared is square root your answer. So do square root of 65 on your calculator, press the S to D button if you need to, and then answers generally to 3 significant figures. And I've got an answer here of 8.06. And I'll just do a little check that that is the longest side on the triangle. 8.06 is longer than 4 and 7. This diagram is not drawn very well to scale, is it? You should put a bit 4 on that side, 7 on that side. But anyway, it's 8.06 centimetres. And then move on to this second question here. Again, we've got a squared plus b squared equals c squared. And on this side is c. C is always the diagonal side on a right angled triangle, always the hypotenuse side. And it doesn't matter what around A and B are, A this side, B this side. Now B is the one I don't know, so I'm actually first going to take away a squared onto the other side. So I've then got b squared equals c squared, and I know c is 18, so that'd be 18 squared minus a squared, and a is 15 squared. Now don't try and shortcut this process and say, well, 18 minus 15 is 3, so it must be 3 squared. No, do it properly on the calculator. 18 squared minus 15 squared is actually 99. And then how do we work out b on its own? Because at the moment we know that b squared is 99. We square root 99. And the answer there, press the S to D button if you need to, is 9.95. And is that one of the shorter sides on the triangle? Yeah, it's the shortest side on this right angle triangle, 9.95. So there we are. So sometimes you need to do your two sides subtracted by each other once you've squared them. That's when you're finding a shorter side. And sometimes you have to add them together, and that's when you're finding the longest side. So you remember that then. When you're finding the longest sides on a right angle triangle, you add the squares, and when you're finding a shorter side on a right angle triangle, you subtract the squares. Okay, let's move on to these questions here. So similar questions, pause the video, give these a go. Let's move on to this one here. So I'll call this side A, this side is C because it's the longest hypotenuse, and this side will be B. So I'm going to use b squared equals 16 squared minus 8 squared. So I'll do that on the calculator, 16 squared minus 8 squared, and that gives me 192. And then the next thing I'll do is I'll square root the answer, and that will give me 13.9 to 3 significant figures, centimetres. So why did I use subtract here? It's because I'm trying to find a shorter side. 16 is the longest side, so it's not going to be an add, it's a shorter side, so I need to use subtract. On this last question here, it is add because I'm trying to find a longest side. We'll maybe call this side A, this side B, and this side will be C because it's always the longest side that we call C. So it's going to be 7 squared plus 10 squared, which would be 149. And then for C, we need to do the square root of 149, so square root of 149, and we get 12.2. So there we are, 12.2 centimetres is the answer to this question. Okay, next questions, pause the video and give these a go. Decide if these triangles have right angles. Okay, well, I know that when triangles do have right angles, they are called A, B and C. And don't be fooled into thinking, well, there's a little box there, so yes, they must be right angled triangles. I might have just put that box in there accidentally. So we've got to test it. We've got to test that A squared plus B squared will equal C squared. So A is the number 6, 6 squared. B is the number 8, so 8 squared equals 10 squared. Let's work out what 6 squared plus 8 squared is on the calculator. Well, it's 100. And it's also 100 on the right. So therefore we have shown that the left-hand side is equal to the right-hand side. That's what LHS and RHS mean. Left-hand side, right-hand side. So it is a right-angled triangle. And you need to write that sentence, otherwise you'll miss potentially one of the marks. So it is a right-angled triangle, because Pythagoras Theorem works perfectly. Okay, and moving on to the next one, it's going to be 4 squared plus 18 squared equals 22 squared. Let's see if it does. 4 squared plus 18 squared equals 340. And then 22 squared equals 484. Nowhere near. This is not even nearly a right angled triangle. Left-hand side does not equal. When you want to say does not equal, you put an equal sign and a line through it. LHS does not equal RHS, so not a right angled triangle. And there we are, that's the answer to this question. Let's move on to the next one. We'll find the diagonal length of this rectangle. So let's draw in a diagonal length from this rectangle. And you can see here that we have a right angled triangle up here. Remember, in Pythagoras Theorem, we're only ever working with right angled triangles. So when you get a right angled triangle with a different shape, you've just got to try and spot where does the right angled triangle belong. And here it is. We have highlighted it here. So we'll call this side A, this side B, and the diagonal will be C. So I'm going to add together these squares. So 13 squared plus 9 squared. I'll do that on the calculator. 250. And then we need to square root 250 to actually get the answer for what C is. So square root answer will be 15.8. So the diagonal on this square is 15.8 centimetres. Lovely, there we are. Let's move on to the next one. Pause the video and give this one a go. Find the height of an equilateral triangle with side lengths of 8 centimetres. Okay, well let's draw one out. So it's 8, 8, 8. Now this is not a right angled triangle. So how can we turn this shape into a shape that has right angled triangles in it? Well, if I divide my shape into 2 down the centre, then that's going to give me a right angled triangle, and it will give me a perfect right angled triangle on either side of the shape. But I'm going to have to halve my base to a 4. So now I can work out the height of my triangle. So what I'm going to do here is I'm going to recognise that the line of side 8 here is the hypotenuse of my right angled triangle. So it's going to be 8 squared take away 4 squared, because in this question I'm trying to find a shorter side on this left hand side right angled triangle. So on the calculator I'll put 8 squared minus 4 squared, and that will give me 48. And the last thing to do will be to square root the 48. Square root 48. That will give me 6.93. 6.93 centimeters, and there we have it. That's the height of the triangle, 6.93 centimeters. So again, it's taking a shape that you're given and forming the right angle triangle, because Pythagoras' theorem only works with right angled triangles. Let's have a go at this one then. Julie puts a ladder against a tall wall on her house. Her ladder is 7 meters long. She places the base of the ladder 2 meters away from the wall. Find the vertical height of the ladder up the wall. Okay, well, let's draw Julie's house. Here's Julie's nice pretty house. Very good. There's the door, there's the window, but we're not really interested in that. We're interested in the ladder that's going to go up the side of the house. So this ladder is side 7 meters long, and we're told that she places the base of the ladder 2 meters away from the base of the wall. So that will be here, 2 meters long here. And we've got ourselves a right angle triangle. Hopefully Julie's house is built at a right angle to the ground. I'll just assume that for this question. So I need to work out the vertical height of the ladder up the wall. That's this height here. Now, in my right angle triangle, 7 is going to be the hypotenuse. So in this question, I'm working out a shorter side on this right angle triangle. So I'm going to have to do 7 squared, take away 2 squared to work out a shorter side. So that's going to be 49 take away 4, which is 45. The last thing to do to work out the height will be to square root the 45, because it's b squared that we've worked out here, and that will be 6.71. So 6.71 meters high up the wall is Julie's ladder. Let's move on to the next one. A square has a diagonal length of 16 centimeters. Okay, let's draw that in. 16 centimeters. Find the dimensions of the square to 3 significant figures. Well, the dimensions of the square will be the width and the height. But on a square, these two things are equal, so I'll instead, don't call them W and H, I'm going to call them X and X. Now what I know is that when I square this side, add this side, I get 16 squared. So that's what I'm going to do. I'm going to do x squared plus x squared equals 16 squared. 16 squared, I believe, is 196. No, 256 rather. 256. On the left-hand side, I've got 2x squareds. So I'll half both sides now to get rid of that 2 at the front. 256, half of it is 128. And then I can work out what x is just by square rooting. So what I've got here now is an equation that needed solving. Divide by 2 first on both sides. And the next thing to do will be to square root. So square root of 128 is 11.3. And that will be 11.3 centimeters. And there we are. So 3 significant figures. 11.3 centimeters is the dimension of this square. It's 11.3 on this side and 11.3 on this side. Lovely, there we are. And another tricky question for you to have a go at then. Find the distance between the coordinates 8, 3 and minus 3, 5. We'll pause the video and give it a go. I'm going to draw it out. So I'm going to go 8 across, 3 up. So 8, 3. And then I'm going to go backwards by 3 and up by 5. So I've got one coordinate here. Okay, and I'm looking to work out the distance between the two coordinates. Now, where on earth am I going to fit in my right angled triangle here? Well, what I'll do is I'll make my own. I'll go down and then across, making sure that I form a perfect right angled triangle. So in my triangle, I need to work out what the base is. And I've gone from minus 3 on the x-axis this way up to 8 on the axis this way. So the base is a distance of 11. And on the height, I've gone from 3 on the height to 5 on the height. So that height there is going to be 2. So now what I've done is I've made myself a perfect little right angle triangle, 2 on the height, 11 on the base. Now let's work out the diagonal. So it's going to be 2 squared plus 11 squared. That would be 125. And then square root 125 and that gives me 11.2. So that's the answer to this question, 11.2. It's not centimetres, it's not anything else, it's got no units on this question, just the value 11.2. And a cheeky bit of three-dimensional Pythagoras theorem here. So first of all, we need to work out the lengths from B to D. So let's draw that in, B to D along the base there. Well, where's the right angle triangle here? Well, the 4 centimetre side over here will match up with the 4 centimetre side over here, and then I can build myself a little right angle triangle along the base of the cuboid there. 4 on this side, 10 on this side, and this side would be the hypotenuse of this triangle. So for BD, it's going to be 4 squared plus 10 squared, and then I'll take the answer and square root it. So 4 squared plus 10 squared, whoops, plus 10 squared on the calculator, and then square root answer, whoops. Oh gosh, I'm getting my stuff on the calculator mixed up here. It's going to be 10.8 to 3 significant figures. 10.77, but make sure you round the 7 properly. Then work out the distance from B to H. So H is in the top corner here, and then I'll go down to B down here. Now that 10.8 centimetre line is coming in very helpful here, because it's now going to give me the base of my new right angle triangle. My new right angle triangle is going to be here. The 6 centimetre diagonal, so 6 centimetre line will match up over this side. So it's going to be a base of 10.8, a height of 6, and then I'll work out the diagonal from B to H. But this side, remember, isn't exactly 10.8, it's 10.77032961. So how can I use that exactly in my calculation? Well, what I could do is on the calculator I could write this out. I could write down answer squared. And there's a button on your calculator that has answer, and that will use the current answer that's been on your calculator screen. So I'm going to press answer squared, and then I'm going to put plus, the other side is 6 squared, so 6 squared, and I'll put it all in a big square root symbol, and that will do the whole calculation all in one go for me, because remember at the end of a Pythagoras calculation you need to square root. And this answer comes out to be 12.3 centimetres to 3 significant figures. And there we are. So it's a perfect example where I can show you to use the answer button to make sure you've got the most accurate answer possible. Alright, let's move on to tree diagrams now then. So pause the video, give this question a go. A bag contains 5 red counters and 9 blue counters. Anne picks 2 counters, one after the other. Find the probability she picks the same colour counter. Okay, well, I could draw the whole tree diagram, and in the first question I'll show you how to draw the whole tree diagram. First pick will be either red or blue, and then after that she picks another counter, and it's red or blue. And if she picks a blue one first, then she's still got the choice of red or blue afterwards. So these are detailing all the options that Anne could pick. She could go red then red, or red then blue, or blue then red, or blue then blue. But we're only interested in going for the same colour, so red then red, or blue then blue. So I'll only bother putting numbers on these branches. The probability of picking a red, first of all, would be 5, because there are 5 red, out of a total amount of counters of 14. Now, after you've picked one red, you've got one red less. You've only got 4 red counters left. And then, after you've picked one of the counters, you've got 1 counter fewer. You've not got 14 counters left in the second pick. You've got to pick out of 13 red counters. And the probability of going red then red, you can calculate by multiplying the fractions together. Now, how do you multiply fractions? It's actually quite easy. You just do top times top and bottom times bottom. I'll just check that on the calculator. 14 times 13 will give me 182. Don't simplify it yet, because I'll bring in something else later on. Now blue then blue, because we want to pick the same colour. So the first probability of picking a blue will be 9 out of 14 counters, because we're restarting from the beginning again. Then it's down to 8 blue counters out of 13 counters in total, once you've already picked a blue one. So the probability of blue then blue is 9 over 14 times 8 over 13, and that's going to be 72 over 182. Now, whenever you need to combine probabilities together to work out either going red then red or blue then blue, you add the probabilities together. And how do you add fractions? Well, as long as the denominators are the same, which they are here, you just add the tops. 92 over the denominator that you've got in common, 182. And now you can simplify your fraction. You can do this on the calculator by using the fraction button, which will give you a simplified fraction of 46 over 91. And there we are. That's the answer to this question. Okay, let's move on to the next one. So a bag contains 6 red counters, 4 blue counters, and 5 green counters. Joe picks 2 counters, one after the other. Find the probability he picks the same coloured counter. Now, I'd be here for quite a while, and I haven't got enough space to draw the whole probability tree. So I'm just going to go for what Joe could pick first. Red, then blue, then green. And I'm only going to draw a tree diagram to answer this specific question. The specific question in context here is find the probability he picks the same coloured counter. So after he's picked red, I'm not interested in picking blue or green. I'm only interested in picking another red. And then it's 2 counters, isn't it? And then after blue, him picking another blue. And after green, him picking another green. There are more options on this tree diagram if you want to draw the full thing, but these are the only branches that I'm interested in to find the actual answer to this question. Now, I've got 6 red out of a combined 15 blue, so it'll be 6 out of 15. But once I've picked a red counter, I can go down to 5 red counters out of 14 counters in total. On the blue branch, I've got 4 blue counters to start with out of 15, restarting from the beginning. And then once I've picked a blue, I've only got 3 blue left out of 14 counters in total. Restart from the beginning to work out the green probability. That'll be 5 out of 15. And then move on to the next one. It's going to be 4, because I've already picked a green one out of 14, because I've already reduced the number of counters by 1. Working out the probability of red then red, you multiply the probability as you go along the branch. That would be 30 out of, I'll just check on the calculator, 15 times 14, that's 210. Remember, to multiply fractions, you do top times top, bottom times bottom. On the next one, blue then blue, 3 times 4 is 12 over 210. And on the green, it'll be 5 times 4 is 20 over 210. And then the final answer, find the probability he picks the same coloured sweet, will be all of these options combined, because it doesn't matter if Joe goes red then red, blue then blue, or green then green, as long as he picks the same coloured counter out of 2. So we'll add these probabilities together. We've got all the denominators the same, so therefore we can just add the numerators. 30 add 12 is 42, add another 20, that's 62 over 210. And make sure you finalise your answer by writing a simplified fraction. That would be 31 over 105. So that's the final answer in this question. Moving on to the next one. A bag contains 3 red counters, 5 blue counters, and 6 green counters. Carl picks 2 counters, one after the other. Find the probability he picks different coloured counters. Okay, well, I'm actually going to do this by a cheeky little shortcut. I'm not going to do all the options here. What I'm going to do is I'm going to basically do this question and then work out what the opposite probability to it is, because the opposite of same coloured counters is the reverse of different coloured counters. So I'm going to sneakily work out the probability of him picking the same coloured counters and then work out the opposite probability. So I'll go red, blue, green again, and I'm looking for the same counter, and then I'll work out the opposite probability at the end. Red, blue, then green. So it's going to be 3 out of 14, 2 out of 13. Then blue is going to be 5 out of 14, then 4 out of 13, and green is going to be 6 out of 14, 5 out of 13. So that'll be 6 out of, what's 14 times 13 again? 182. On the next one it's going to be 20 over 182, and on the next one it's going to be 30 out of 182. Combine these probabilities together, and the probability of picking the same counter out is going to be 56 out of 182. But the actual answer to this question is the reverse probability to this, the opposite probability to this. And the opposite probability would be 182 take away 56. That would be 126 over 182. Or in fact, we should probably write this as a simplified fraction. Divide that by 182. And that would give me 9 out of 13. So 9 out of 13 is the probability for picking different coloured counters, and I've done it in a bit of a sneaky way. I've worked out the probability of the same coloured counter, that was this answer here, and then I've done the reverse of that probability, the complete opposite of it. I've done 1 minus 56 over 182 to work out the actual answer to the question that I'm asked, which is 126 over 182 simplified to 9 over 13. Sneaky. Alright, let's move on to a bit more of a challenging question here. Anne and Sophie are sharing a bag of sweets containing 5 cherry and 7 blueberry sweets. Anne picks first, then Sophie, then Anne again. Find the probability that Anne picks 2 blueberry sweets. Okay, so I'm specifically looking for Anne picking 2 blueberry sweets. So the first pick is Anne. And Anne only has one choice if I'm looking to answer this question, and that's to pick a blueberry sweet. So I've got 7 blueberry sweets on offer out of 12 in total. Then after Anne picks a sweet, then it's Sophie's turn to pick a sweet. Now I don't care what Sophie picks, she can either pick a cherry or a blueberry sweet. I'm not fussed. The amount of cherry ones that are left after the amount of cherry ones left after Anne's picked a blueberry sweet will be 5 out of 11 sweets. And if Sophie picks a blueberry sweet, there are only 6 of those left out of 11 sweets. Now that's Sophie's pick that I've just detailed here. Now I'm back to Anne, and I only care about Anne picking a blueberry sweet. So I'll only draw the branches for blueberry. Anne then has the probability for picking a blueberry on a second time round. There are only 10 sweets left in a bag, because Anne's already picked one and Sophie's already picked one. So there's only 10 left. And how many blueberries are left? Well, she's picked one out here, so we're down to 6 here. Then Sophie picked a cherry, so that didn't matter. So there are 6 left here. Let's go down to this probability down the bottom here. Anne's picked a blueberry, then Sophie's picked a blueberry, and now we want the probability of Anne picking a blueberry again, so we're down to 5 blueberry sweets down here out of a total amount of sweets of 10, because we've already picked 2 out of the bag, 2 that are blueberry. So what we need to do now is work out the combined probability, so the probabilities of going blueberry for Anne, cherry for Sophie, then blueberry for Anne, and then blueberry for Anne, blueberry for Sophie, then blueberry for Anne again. So it's going to be multiplying 3 probabilities along the branches here. You multiply top by top by top, so that would be 7 times 5 times 6. I've just done it on the calculator. 210 over 12 times 11 times 10. I'll do that on the calculator as well. Why not? 1320. Then the probability of going blueberry, blueberry, blueberry will be 7 times 6 times 5, which is again 210, over 1320. And then the combined probability of this, why are we combining the probabilities here? Because all we're looking for is to make sure that Anne had a blueberry, then a blueberry sweet afterwards. It didn't matter to us what Sophie picked, as long as Anne had her 2 blueberry sweets. So we'll combine these 2 options because we don't mind which route we took on the tree diagram. So it would be 420 over 1, 3, 2, 0. And I'll simplify this probability, like I do with all my final answers, to 7 over 22. And there we are, that's the answer to this question. Okay, and we'll now move on to simultaneous equations, question 6 out of the end of year exam. So, how do I do these questions? Let me show you. So make sure you've paused the video and given this one a go before I show you. We'll call this equation 1 and we'll call this equation 2. And what I can spot out of the equations is that yes, the x numbers are different, but the y numbers are the same, which makes this an easy level question. I'll spot that the x is bigger on the equation 2 than on equation number 1. So what I'm going to do is in the columns, I'm going to take away equation 2 and equation 1. So 2 take away 1. So in the columns, 5x on equation 2 take away 3x on equation 1. And that'll be 2x. 4y on equation 2 take away 4y on equation number 1, that'll be nothing, and that's perfect. That's why you always want to happen when I start adding or taking away equations. I want one of the letters to just cancel out. And then equation 2 take away equation 1, 37 take away 27 in the column, that'll be 10. So nicely I've got a little equation here which is 2x equals 10, and it's obvious now that x is equal to 5. Now that I know that x is equal to 5, I can go back and put that into one of the equations. I usually like to pick the equation with the smaller numbers. I'll take equation 1 in this case. I know x is the number 5, so 3 times 5, that's 15. And then I'll write out the rest of the equation, plus 4y equals 27. I'll then take away 15 away from both sides, so that'll leave me with 12. So take away 15 on the right and take away 15 on the left. And then divide both sides by 4 and I get y equals 3. So there we are. Highlight the answer, x equals 5, y equals 3. And that's the answer to this question. Now, it's not always going to be that easy. This question was a pretty easy level difficulty one because we perfectly have 4 y's on both of the equations. Let's have a look at what happens when it's a little bit more difficult like this question here. Now, assessing the questions, I can see that if I've got 4 and 2 on the x and 3 and 5 on the y. Now, what I can do is if I take the second equation and double all of the numbers, then the 4x will match up. So I'm going to take equation 2 and double it, times it by 2. And I double the whole equation here, so it's going to be 4x, 10y, and double 28, I'll quickly do this on the calculator just to make sure I don't go wrong, 56. And this has to be given a new number equation. We'll call this equation number 3. And now what I've got, if you can highlight here, equation number 1 and equation number 3, the x's perfectly match up. So now what I can do is I can assess the y's, and I'll like to do 3 take away 1. So, in the columns, 4x take away 4x, that's 0. 10y take away 3y, that would be 7y. And 56 take away 42, that's 14. So I nicely get here that y is equal to 2. And just to reassess the question here, what I've done here is perfectly organised the equations so that one of the letters is equal to the other coefficient. So it might be y's, it might be x's. In this case it was x's. That was the easier one to make equivalent. But what I now need to do is I need to go back to one of the equations. Doesn't matter whether it's 1, 2 or 3, and put in the equation y. I think I'll pick the first equation, and I'll write 4x plus, and then I'll put y in. 3 times y is the number 2, so that'll be 3 times 2 is 6, equals 42. Take away 6 from both sides to leave me just with 4x, and 42 minus 6 is 36. And then divide by 4, and I get x equals 9. So the final answers here are x equals 9, y equals 2. And there we are. That's kind of like a medium level difficulty question, because I've only had to multiply one of the equations by one number. Let's see what happens when we have got an equation like this though. So what could I multiply one of the equations by? Is there anything that I could multiply 2 by to get to 5, or 2.5, but that's not great. Is there anything I could multiply 2 by to get to 3? Well, 1.5, but still that's not great. What I'll do in this question is I'm going to multiply 2 of the equations, all of the equations, to make y the same. So I could multiply both of them up to make it 6y on both of them. So I'll take equation 1 and double it. And that will make it 10x plus 6y equals 10. And we'll call that equation number 3. And then for second equation, I will triple it. And that will give me 6 on the y as well. So it will give me 6x plus 6y equals 18. And I'll call that equation 4. Now the y's perfectly match up. So what I'm going to do is I'm now going to do equation 3 take away equation 4, because that will give me a positive x number, so that will give me 4x. 6y take away 6y, that's cancelling, and then 10 take away 18, that will give me actually minus 8. So be aware, you do sometimes get negative numbers in these sorts of questions, and make sure you take them away in the correct order. In this order, it's 3 take away 4. So I've done 10x take away 6x to give me 4x, but I also need to do it in the same order. 10 take away 18 is minus 8. So x here is minus 2. Make sure you don't forget that. You have to take it away in the same order all the way throughout the equation. I've chosen 3 take away 4. Once I've worked out that x equals minus 2, I'll put it into one of the equations. I'll choose equation 2 for this one. So it's going to be 2 times x is minus 2, so that'll be minus 4, add 2y equals 6. Add the 4 onto the other side, because at the moment it's negative, so add it onto the other side, you get 10, so then y equals 5. So the answer to this equation is x equals 2, y equals 5. And there we are, that's the answer to this question. Moving on to the next one. Now, what I've spotted here, just upon observation to start with, is that I could make the x letter 12 in both cases. And that'll be the easiest thing to do. So I'll take equation number 1 and I'll double it. So take equation number 1 and times it by 2. And that will give me 12x minus, I'll multiply everything by 2. So 14y equals 57 times 2, that's 114. Yeah, I just checked it on my calculator as well. That would be equation number 3. And for equation number 2, I need to triple it to make the x 12. So that's going to give me 12x, 9y, and minus 8 times 3, minus 24. Now, this is where people always struggle with simultaneous equations. It's the negative numbers. When negative numbers are introduced to simultaneous equations, that's where students go wrong. So make sure you're really paying attention here. I've got 12x and 12x. So which way round would it be easiest to subtract? I think I'll do 4 take away 3, because I've got 9y as the bigger number. So it's 4 take away 3. Now in the columns it goes 12x take away 12x. That's 0. That's what I wanted it to do. Now be careful here. It's going to be 9y. I'll write it out on the side. 9y. Subtract, because that's the operation between the two equations, the number minus 14y. Minus 14y. Now what do you do when you have a taken away a negative number? What do you do when you take away a negative number? You add it. You do 19 add 14. So 9y add 14y, and that will give you 23y. And again, what do you do? So it's 4 take away 3, so I have to do it in that order. Minus 24 take away 114, that will give me, well, I'll do it on the calculator just to make sure I've got it right. Minus 24 take away 114, that will give me minus 138. And then fingers crossed, when I divide minus 138 by 23, I get minus 6. Lovely, so there we are, we've got the correct answer of minus 6. But don't stop there, we need to now plug it back into one of the equations to work out what x is. We've only half done this question. 4x minus 18 equals minus 8. Add your 18 onto the other side, you get 10. So then x is equal to 2.5. So the answer to this question is x equals 2.5. You always write the x one first. Y equals minus 6. And that's the answer to this question. So be really careful of your negatives here. Your double negatives and you're subtracting negative numbers from negative numbers as well. That's where students go wrong. And let's move on to the next one. We've got decimals in there as well. So I think what I'll do here is the easiest numbers to work with will be the y numbers, I reckon. If I take equation number 1 and double it, then I'll get a 6 on the y. And if I take equation number 2 and triple it, then I'll get a 6 on the y as well. So equation 1 times 2 the whole way through it, that would be 10x minus 6y equals, I'll do it on the calculator, 13.5 times 2 is 77. We'll call that equation number 3. And then tripling the third equation, that's 21x plus 6y equals, and then 41.5 times 3 gives me 124.5. That's equation number 4. Right, now here is another place where students sometimes go wrong. Yes, I've got 6y and 6y here, but one's positive, one's negative. So how am I going to cancel these two y's out? Because usually I subtract them, but that's always when they've been positive. If we look back at the questions we've done so far, it's 12x, positive 12x and positive 12x. So I take them away, because positive take away positive is 0. This one's positive as well, positive and positive, that needs a subtract. This one here was 4x and 4x, they're both positive, so they need a subtract. What do we do when one is positive and one is negative? Well, the easiest way, so the way that you should be doing this question to make the 6y and the minus 6y cancel out is actually to add the equations together. Why is that? Because when you do minus 6y, add 6y, what happens? You get 0, because one's positive, one's negative. So the way you cancel out something that's both positive and negative is by adding it together to give you a 0. So that's what we're going to do. We're going to add the equations here. So let's add them in the rows then. So it'd be 31x plus nothing equals, then on the calculator, 124.5 add 77, which will give me 201.5. Now let's cross our fingers and hope that a nice simple number comes out. 201.5 divided by 31, cross our fingers, is 6.5. That's pretty easy, pretty friendly number. Okay, so now that we know that x is 6.5, let's put it back into one of the equations. Let's put it into equation number 1. And I'm always checking my answers on the calculator here. So 5 times 6.5, I won't try and do it in my head. I'll use the calculator. 32.5 it is, minus 3y equals 38.5. Then I suppose I will add the 3y onto the other side and take away 38.5 onto the other side. I get minus 6 equals 3y. So therefore y is equal to minus 2. So the answer to this question is x equals 6.5 and y equals minus 2. So there we are. We've got a couple of questions where we have to do different things on the simultaneous equations. When we have to multiply two different equations by different numbers, sometimes you need to add the equations, particularly when one is positive, one is negative. And then another one back here where you have to be very careful about your negative numbers on your simultaneous equations. Alright, and that's all we're going to go through this video then. So in the next video, we'll have a look at questions 7, 8 and 9, circle theorems, trigonometry and median and mean. So watch these MathsWatch clips on MathsWatch, and lovely. Hopefully I'll see you there next time. Thanks very much for watching. Hopefully you found this useful.